Alright, so in this one I am going to be talking about raycasting, right? How to cast array, what raycasting is, how it works, and how can we use raycasting effectively. I'm going to open up a paint window so you can actually see what raycasting is. Now keep in mind, if you don't understand what I'm talking about in this video, I have videos explaining everything. Don't come complaining to me, go watch my other videos. You can't just jump to a video and expect to straight understand it. You gotta walk before you can run. That's essentially the term. So that I'm going to create two blocks here. I'm gonna call this one Jimmy. Yeah, why not? We're bringing Jimmy back, and we're gonna call this one Hey. Right? Yeah, sure. Why not? So right now, what if we wanted to detect if Hey is near Jimmy? Well, we could use the theoretical position of or the vector point of the thing, right? The position. So like 1, 1, 1. It would be 1 degree or one position point on the here. Let me open properties. Like this position, right? Well, we could detect if the position of this is equal to the position of that, right? But only if it was equal to. And if we did that, well, that's not very accurate because the ray could have hit it, but like it wouldn't be very accurate because it could move and it wouldn't be equal anymore. So the most effective way to do that is doing raycasting. So essentially what that does is we're going to literally cast our little invisible line to Jimmy, or however the far Jimmy is. Once we cast that, the ray will not continue. It will stop once it hits. It will not go through Jimmy. It will not like go there. It won't go through continuing. It will stop once it hits an object. So now we can say, "Hey, just realized I hit something named Jimmy," and it will give the position and other information about the hit object. Now, we could cast multiple rays, but I don't recommend that. One is usually enough because you don't need to, unless you want to do like some crazy stuff like this. Detect the height of the object. I don't think that's really necessary. But right now we're just focusing on basic ray casting. So then we have this, right? We're casting a literal laser. That is ray casting. Casting a laser to find an object. Now we know what ray casting is. Let's ignore this game. Let's go back to the studio and let's make it in code. I'm going to make a simple part. So this part is going to be called Hey. Yeah, we're going to call it Hey, like in the video. Or like in the paint. So Hey wants to know if there is something above it. Well, I'm going to duplicate Hey, and I'm going to put it above it, about there, and I'm going to name this Jimmy. So Hey wants to know if Jimmy is directly above the thing, right? Well, like I said, we could get the literal position, this right here. Let me copy this. We could get this position right here, but that's complicated, and we'd have to do math for that, and we don't like math. So how would I tell if something's ahead? Well, we have to create a script inside of Jimmy, or Hey. Sorry, we have to create a script inside of Hey. Now the first thing we have to do when we're doing raycasting, we have to get the object that it's going to spawn from, the position of that object, and the direction it's going to go. Those are the key things in raycasting. I'll show you. So the position, the start position, the part start position, the direction, the hit, and the position. These are the essentials for raycasting. Without these, you cannot make a ray. So I'm going to start with the first thing. Get the part start position. I'm going to get where the ray is going to originate from, or where it's going to start. So local Hey equals script.parent. So now we have Hey. Hey wants to cast a ray, right? It wants to start where the part is. So it wants to start where Hey is. So I'm going to literally do parent.position, right? Or if you could do this. You could do start hey dot position, right? And I'm gonna do a while loop so I can loop the array, and I don't have to copy and paste stuff. Tab that and the loop. There we go. So this create a while loop. Like I said, if you don't know what I'm doing, please don't complain to me unless you watch my video. If you don't know what I'm doing, you probably haven't watched any of my videos. So now we have the start position. So you can cross this one off the list. Right? This is done. Now we need to actually get the direction, right? So I'm just going to do equals vector3.new 0 500 0. So we're going to literally cast a ray above, directly going straight up from the part. It will go straight up on the y-axis. So it'll go like this. Straight up from the part. Right, because we want to detect if something's above it. Can I rotate the image here? No? Can I? It would be essentially saying if hey is going to basically do this. Right? It's going to tell if something's above it. That's what we're doing with the 500. So it'll go 500 studs above the part. And it will detect if something's in that area. So now we have the direction we're going to go. Now we need to do the array, the actual array, right? So we have to make the array. 4 essential things, sorry. We have to get the part position, the direction, make array, obviously, and we have to tell if that array hit something. So I'm going to do local ray cast equals ray dot new. This will literally create a new array. We are calling upon the instance array, and we are creating a new object ray. Ray.new. It's a similar to instance.new. We're calling upon the instance method, and we are making a new object. Well, in this case, we're calling upon the array instance, and we are creating a new array. Now, if you look inside of the... Let me remove them. Actually, maybe if I hover. No. Okay. If you do that, you'll notice it says ray.new. Vector origin, vector3 origin, vector3 direction. So we have the start position, which is the origin. So we're going to do start position, comma, and then we have the direction, the vector3 direction. We're going to do direction. Now we created array. We do local hit. Now that we created array, it will go from the start position. It will go here, and it will cast array going upward, and it will detect anything directly above the part. So now, if we look at our steps, we made the array, that's good. Now we need to get a hit, if it hit. So we're going to do local hit position equals game.workspace, find part on array. Now this takes one parameter, the raycast. The raycast variable we created, the array. Then we're going to do, right, so the hit will be the object that it hit. If there was anything in there, it will be a hit. If there was nothing directly above it, it will be nil. If the array did not hit anything, it would be a nil value, and it would just be nil, nil, nothing. And then, regardless of what it hit, there will always be a position, because that's where the vector ended. That's where the array ended. We gave it 500 as the size of the direction. It will go up 500 studs, and then it will print the position 500 because it didn't hit anything. Now, if it hit something, it would hit where it will print the position that it hit. And I'm going to do that now. I'm going to print hit and position. So now, if I run the game, we notice Jimmy. Hey, Jimmy is indeed directly above us, exactly 51.09 studs. So I'm going to round that to 52 studs, right? Well, if we look at Jimmy's actual position, it's a little off. It's 51, but it's 59, not 09, but it's rough estimate. So if we do this to 500, and we do 500 like this, we'll notice that Jimmy, it's still hitting because he casted array 500 studs above the ground. Now if we do 501, we'll see that it's now nil because it's not casting array any further. Right? You see it's hitting 500, but it doesn't see anything within 500. The position of the part, the start, it doesn't see any objects. It's not hitting any objects from the distance between the starting point and the direction or the end point. So that is essentially raycasting. Now you could, what if you wanted to make an array that changes the color of the part? Well, that's really simple. We'll just do if hit then. So this will say if there's a hit and hit is not nil, right? We're going to do hit dot brick color equals brick color dot new random dot random, and we're going to do 1 second wait. So now we notice every second it changes the color of the thing, or the part, right? See? Now we can make a change. Now if we move the part, it's not going to do that anymore because it doesn't exist. But if we move it over top of it, it will do that. See, look. Because it's hitting the ray. That is raycasting. That's literally how it works. I will be making more tutorials on how to use guns and raycasting eventually. See ya.